What's going on? How we all doing? It's Monday. Did we all have a good weekend? Only 3 viewers of my 35 kids. See, you guys are the good kids. The rest sleeping in past 10:30? Like, what's that? What is that? All right, well, since no one is going to say hi to me, I guess I'm just going to start. I'm a little miffed. Let me adjust that. Good morning, Hannah. Did you have a good weekend? Or was it a little boring? A lot of Animal Crossing. Is that the new game to play? Is Animal Crossing? My weekend was pretty good. I'm not gonna lie. It was relaxing. It was restful. I got a few things that I needed to get done. Um, Lots of new things going on in the school district that are swirling, so gotta get on top of that. But so yeah, Animal Crossing. I notice on Twitch that it's one of the highest playing games. That's funny. I can't wait for Final Fantasy VII, the remake. I don't even know if it's out right now. Is it out? Am I missing out? It's not even close to being out. Wait, what? Oh, April 10th. April 10th. The date was backwards when I was looking it up, and so it looked like it was saying October 4th. I was like, wait a minute. I thought it was April 10th. It is April 10th. Yeah. I'm excited to play that game. All right. Can you guys hear me okay? I'm hoping that I readjusted the microphone. It was somewhere like here, and now it's here, and I think it will pick up my voice a little bit better now that it's there. All right. So, going over this lesson, basically, we are going over these are mainly the cases where we have the case where the numerator was higher than the denominator. So, for example, on number 1, I have x squared minus x over 3 minus x. So I have, looking for the information, I have a vertical asymptote. My vertical asymptote is at x equals 3. The way we figure that out is by setting the denominator equal to 0. And then we have a horizontal asymptote. And the horizontal asymptote, if we compare the degrees, it's 2 and then that's 1. So it's not a horizontal asymptote, but it's going to be an oblique or slant asymptote. So the way we find that out is by dividing it. Now, I'm going to rewrite this. Instead of saying 3 minus x, I'm going to say negative x plus 3. and then placeholders. Now, the reason why we want to rewrite that is just because, like I said, when we're talking about abstract numbers, we want it to go thousands, hundreds, tens, zeros. Technically, when we start talking about abstract numbers, like variables, technically you could rearrange the hundreds and thousands and they have the same meaning. And so what we're doing is we're making sure that they're arranged appropriately, because when we go to divide, we want to make sure that we divide the correct columns. So then negative x and x squared, those are going to divide. And so you're going to get negative x, because you get x squared over negative x. Then these are going to distribute. So we're going to get x squared and then minus 3x. Subtract. So you get 0 and 2x. Bring down the other value, which is 0. So negative x goes into 2x. Negative 2 times. Anything else that I do is going to be a remainder. So this right here, y equals negative x minus 2, that's going to be my oblique asymptote, or slant asymptote. So now I can start putting the values on the graph. And I'm going to make this a little bit larger because I'm probably going to have to plug in points. So I have my vertical asymptote at x equals 3. And then so we have that. Did I choose a color that doesn't come up very well? No, it comes up fine. And then I have my slant asymptote. So that's a line, and I want to graph this line here. And so down 2, and then it's going to go down 1 over 1, down 1 over 1. And so this line here, that's going to be my slant asymptote. So now I have to figure out how is my graph going to fit around those two asymptotes. And so we're just going to plug in values. We're going to plug them in, simplify it, plot them, and then we're going to check on Desmos to make sure that we did everything correct. So creating my chart. So mainly I don't know what's going to happen on each side of these asymptotes. So I want to pick values on each side. So the values that I'm going to pick are going to be like 2, 1, and 0. Because that's going to be on this side. And then values on this side are going to be 4, 5, and 6. And so we're actually just going to take those values and plug them in. So if I plug in 2 squared minus 2 over 3 minus 2. 2 squared is 4. 4 minus 2 is 2. 3 minus 2 is 1. So that's going to be 2. Now we can go through and we're going to find all those values. Now I'm just going to kind of save us some time. I'm just going to go ahead and enter those into a calculator. And I'm going to use the Desmos calculator to be able to do that. I would practice using like maybe the TI-84 calculator or whatever scientific calculator that you have. I'm just doing this, like I said, to save some time because I'm just going to convert it into a table to get the points. So at 2, it's 2. At 1, it's 0. At 0, it's 0. And at 4, it's negative 12. At 5, it's negative 10. And at 6, it's negative 10. Okay. So this is enough information for us to be able to graph what we need to graph. So plotting these points, at 2, we said it's 2. At 1, it's 0. And at 0, it's 0. Now, what this means is we know that the graph wants to hug the asymptotes. And so because it wants to hug the asymptotes, I know that it's going to follow this asymptote here. It's going to cross through. It's going to do a little dip thing. And it's going to come back. And it's going to want to cross this asymptote. So they will never go flat. It's just the way that it's going to go through. It's going to pass through both. Let me clean that up a little bit. Now, like I said, it's not perfect. It's just a sketch. Now, at 4, we said it's negative 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So at 4, it's negative 12. At 5, it's also negative 12. Sorry. At 4, it's negative 12. I don't know why I put negative 112. At 5, it's negative 10. And then at 11, it's negative 10. So then this one, once again, it's going to follow the asymptote, cross, and follow the asymptote. The orange is my asymptote. Make that a little darker. Get rid of that little dot. And so that's what the sketch should look like. And let me show you what it looks like on Desmos. Looks pretty similar. Let me type in the asymptotes. So we have x equals 3. And then we have y equals negative x minus 2. And so there are the two asymptotes. I'll make those dots to make them a little cooler looking. All right, so any questions on those? See what I mean about see how it passes through? It doesn't just go straight, but it passes through and it's still kind of curvy. And the same thing up here. Passes through, it's just a little curvy. One of the assumptions that it just kind of takes practice visualizing is just remember that the graphs want to hug the asymptotes. So they want to approach it and they want to get as close as they possibly can to that asymptote. So they want to hug the asymptotes. And so in this instance, it's hugging the asymptote. It's hugging the asymptote. And that's why we plot a few points, because obviously there's a gap here. I didn't go in that gap. So the points allow me to at least have some direction at where it's going to go. All right. So since no questions on that one, let's look at another one. Let's look at... I don't know. Which one should I do? I'll let you guys pick. Number 3? All right, let's do number 3. All right, so for number 3, what I want to go ahead and do is I want to factor that. So here, let me write it. X cubed plus 2x squared plus x over x squared minus x minus 2. So factoring this, that's going to factor into x times x squared plus 2x plus 1. And the bottom, that's going to be x minus 2 and x plus 1. On the top, it's still going to factor some more. And so that top is going to factor into x plus 1 times x plus 1 over, and in the bottom, we have x minus 2 and x plus 1. Comments or questions on that? So the first thing that I notice, those cancel out. So that tells me I have a hole where x is -1. I can't forget that. I'm going to come back to that later. Now I'm going to look at the rest of my graph. I'm going to look at this piece right here. And with that, that's going to give me a vertical asymptote at x equals 2. Now, if I multiply that x back through, that's going to give me x squared plus x over x minus 2. My degree on top is larger. So because my degree on top is larger, I know for a fact that it's going to have an oblique or slant asymptote. So I need to divide them. So dividing this, x minus 2, x squared plus x plus 0. So x goes into x squared x times. Distribute that. Subtract. Divide again. So you get plus 3. Now I don't have to worry about the remainders. I'm just focused on that. So my oblique or slant asymptote is going to be y equals x plus 3. So now plotting those, I have x equaling 2. That's my vertical asymptote. And then I have the oblique asymptote of y equals x plus 3. So it's a line, starts at 3. My slope is 1, so it's going to go up 1 over 1. Now I'm going to move, let's see if I can do this. I'm going to move this a little bit because I have a feeling I'm going to need to. I'm going to move that, make sure it's not blocking anything. I'm going to move that right there. And the reason being is because I'm probably going to have to extend this out a little bit more. And I'm not blocking the camera, so good. Okay, just in case I needed to extend that more. So now I just need to plug in values. Now, for the x equaling -1, I know it's going to have a hole, but for the plugging in values part, I need to know what the shape of my graph is. So I'm not worried about plugging it in as long as I'm plugging it into this function here. So in creating my table, I'm going to pick values 1, 0, and -1. That's on this side. And then on this side of my vertical asymptote, I'm going to pick values 3, 4, and 5. So once again, I want to use Desmos just because it's going to be quicker plugging in those values instead of it just being super boring while I plug them in. So for my first one, if I plug in 1, I get -2. If I plug in 0, it's going to be 0. If I plug in -1, here, wait 1 second. I'm going to plug in the reduced function. I just want to make sure. Good. And okay. So plug in a -1. I also get 0. And then for 3, I get 12, 4 I get 10, and 5 I get 10. Okay, so let's plot these. So for 1, we said it was -2. For 0, it was 0. And for -1, it was 0. So that means that drawing them, make sure they're hugging the asymptotes. So it's probably going to do something like this. It's not perfect smooth, but I could probably draw that a little smoother, but that's okay. That's good enough. Then on the other side, I have 3 is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 4 is 10. And then 5 is 10. And so once again, hugging the asymptotes. And so that's going to be the sketch of the graph like that. Now I said we can't forget about the hole. So what does that look like on the graph? Well, I need to go where x was -1. And what you're going to do is you're going to, on that graph, you're going to replace x equals -1 with a little open circle. And that little open circle there indicates the hole. It's how we diagnose the hole on a graph, is we put an open circle where that was on the sketch. Let's just say hypothetically, this is hypothetical, let's just say the hole was at x equals -4. So I would go over to where it's 1, 2, 3, 4. I would go over to where I sketched it. This is where the hole is. And so you would get rid of where the rest of the graph is. And you would replace it with the hole. And so that would be the sketch of the graph. Dude, 1 second. Oh. Okay. Something was like happening on my computer and it was like bing, 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 bing. And I'm like, what the heck? Okay, questions on that? Let's look at it, what it is on Desmos. Here, I'll make it smaller. So like you can see, has a very similar, the image, there's the asymptote there, there's the asymptote there, And it follows that very similar pattern, right? It's not flat, it's curved as it passes through. All of these are the same pattern. Now, as a trick question, I threw it out there for number 4. That is not an oblique or slant asymptote, right? That's going to have a horizontal asymptote at y equals 0 because the denominator is larger than the top. Okay, for number 5, it says find all the zeros to the polynomial, then factor it completely over the real numbers and factor over complex. So for number 5, we have f of x equals x to the 4th plus 9x squared plus 20. So this is a quadratic type equation. So if I say u equals x squared, I'm going to get u squared plus 9u plus 20. And this will factor. That'll factor into u plus 5 and u plus 4. Set each one equal to 0. U plus 4 equals 0. U equals -5. U equals -4. Square root both sides. I'm going to get x equals the square root of -5 because I plugged the x squared in my head because u is really x squared, right? And so x equals the square root of -4. And so x would equal root 5i plus or minus. And then x would equal 2i plus or minus. So those are all the zeros. Now when it says factor over real, well, whenever I did anything here, all of a sudden I got imaginary. So factoring over real, that's just going to be x to the 4th plus 9x squared plus 20. And then factoring over the complex, that's going to be x minus 5 root 5i, x plus root 5i, x minus 2i, oh no, x plus 2i. That's supposed to be right next to it. It got blocked off. So these are my zeros. Those are the real, those are the complex. Comments or questions on that? Okay. I'll start you guys off with number 6. So with number 6, it is not a quadratic type equation. So this is where we have to do the p's over q's. So it's going to be the factors of 4, 1, 2, and 4 over the factors of 8, 1, 2, 4, and 8. And so you have to do all the combination of these p's over q's with that. So 1 over 1, 1 over 2, 1 over 4, 1 over 8, and then 2 over 1, 2 over 2 is 1, 2 over 4 is 1/2, 2 over 8 is 1/4, so I don't have to repeat them. And then 4 over 1, 4 over 2 is 2, 4 over 4 is 1. 4 over 8 is 1/2. I don't have to repeat them. So this will be my list. And then, so these are the ones that we're going to test in the box, right? So 1, test -1, and break it down and factor it. Okay, on number 7, it says create a polynomial which has the desired characteristics. You may leave the polynomial in factored form. So it says the zeros of the polynomial. So I can immediately just write x minus my 0. There's +2. There's -2. There's +1 and -1. Well, if I multiply x and x and x and x, you get x to the 4th. The second thing it says is it wants 117x to the 4th. So if I put 117 in front of that, that would put 117 in front of that. And so this would be my polynomial with those given characteristics. Okay, for number 8, it says find the area of the triangle. So for these, I'm going to pull out that lesson so you can take a look at it. If you guys remember, we went over different applications with the area of the triangle. And so, like on let's say number 9, if I were to draw this triangle, A, B, C, this is 90 degrees, B is 4, and A is 3. Well, the relationship is side, angle, side. And so when it's side, angle, side, there is a formula for it. And so in this case, it's 1/2 B times C times the side of the given angle. So if you look at the picture, A is the given angle, B and C are the two sides right next to it. So here's my given angle, and then these are my two sides next to it. So this is going to be area equals 1/2 my two sides times the sine of 90 degrees. Well, 1/2 times 4 is 2. Sine of 90 degrees is 1. So that gives me 6. And it doesn't give me any measurements, so I'll just say units squared. So just remember there were those 3 formulas. And I'll make this larger so you can look at it. This was it was angle, side, angle, or angle, angle, side. This is when it was side, side, side. And this is when it was side, angle, side. Comments, questions on that? Okay. Number 10 says graph the quadratic function, find the zeros, x, y-intercepts, etc. Okay, so I have x squared minus 4x minus 3. So it's going to be easier if I put this in graphing form to be able to graph it. So I'm going to put parentheses around that part. Then complete the square. So -4 over 2 squared. So b over 2 squared. That's going to give me 4. So I'm going to add 4. And subtract 4 inside the parentheses. This will factor. That'll factor into x minus 2 times x minus 2. And I still have the minus 4 and the minus 3. So that's going to become x minus 2 squared minus 7. Now that I have it in factored form, my vertex is going to be 2, negative 7. So drawing the sketch, 2, 2, 3, 4, 5, 6, 7. The angle is all weird. 1 second. Camera. And so aha, you guys saw my keyboard. Cool keyboard. I can make this draw. I can draw this a little neater. 1, 2. There we go. Little neater. Then the rest of the question, it says find the x and y-intercepts. Well, to do that, the y-intercept is negative 3. So that's easy. So y-intercept is 0, negative 3. To find the x-intercepts, you just set it equal to 0. So if you set this equal to 0 and solve, you can find the x-intercepts. My domain is negative infinity to positive infinity. My range starts here at negative 7 and it goes all the way up. So from negative 7 to infinity. Intervals of increasing and decreasing. So if I examine it this way, as I move this way, my graph is going down. So that's going to be decreasing from negative infinity until I get to 2, which means it's going to, as I move this way, my graph is going up, so it's going to be increasing from 2 to infinity. And then I have a minimum of negative 7. And my camera blocked it. I apologize. There you go. So any questions? Because other than that, we are done. Perfect. Well, if you guys don't have any questions, just hit me up in Discord. Other than that, have a good one, guys. I will see you tomorrow. I believe tomorrow's lesson is 72-1, but let me double check just to make sure. 72-1 it is. Yeah, we're going to be solving rational equations. Woohoo! Yep, but we're out of graphing. We're moving back into solving. But we're moving right along. Thanks, Hannah. You have a good day too, okay? All right, guys. Have a good one, and I'll see you tomorrow.